How would we find the equation of a quadratic function if we're simply given the roots and a point, or the vertex? Well, let's look at some examples. Let's say I'm told that the roots of a function are x equals 3 and x equals -5. And I'm also told that we have a point on the function, and that point is -8, -10. We don't know that this is the vertex or anything like that. We just know that this is a point on the function. So to start, I like to sketch what we have so far. So you have your xy axes like that. And we know the roots are 3 and -5. So 3, -5, just like that. Now so far, we don't know if this graph opens down like this or if it opens up like this, right? We don't know which one it is, and we also don't know how much it's been stretched, right? We don't really know a lot of things. So what we have to do is put the information we have so far, mainly the roots, into an equation. So y equals x minus 3, x plus 5, right? Because that represents your roots, 3, -5, so you put minus 3 plus 5. The only other thing that we don't know is the number that's on the front, because you could always have a number on the front of your factored form, right? That represents your vertical stretch or compressions as well as reflections if it's negative. So we'll just call that A for now. Now how would I find A, right? Because that's going to tell me the direction, it's going to tell me how skinny or wide this is, because it could look something like this, right? It could be very wide like that, or it could be more something like that, right? Like we don't know exactly what this quadratic looks like. So to solve for A, what you have to do is plug in that point for x and y. So your y value, you'd say is -10, and your x value, you would say is -8. So -10 is equal to A times -11 times -3. So 33A is equal to -10. Divide both sides by 33. A is equal to -10 over 33. So your final answer would be y equals -10 over 33, x minus 3, x plus 5. Now what does this tell us? It tells us that the A value is negative, meaning that the graph opens down. So the general shape, you could draw something like this. And this makes sense that it opens down because again that point was -8, -10. -8 is way over here on the left, -10 is down here. So you couldn't have a graph opening up like this because that point would be up here, right? But it's at -10, so it must be, down here somewhere. So this answer does make sense for us. Now, when you're sketching these graphs, one thing that you would like to do typically is you would want to write where the vertex is and maybe label the y-intercept as well. To do that, right, to find the y-intercept, all you would have to do is sub in 0 for x into your equation down here. If you do that, you'd have -3 times +5 times -10 over 33. And if you do that, the y value you're going to get is 50 over 11, which is about 4.5. So this here is 50 over 11. That's your y-intercept. To find the vertex here, you just have to find the x value that's halfway between -5 and 3. So take the average of those two, and if you do that, you're going to get an x value of -1. And then to find the height of that point, you simply have to plug in -1 into your equation down here. And if you do that, you're going to get the point -1, 160 over 33. And 160 over 33 is about 4.85, so a little bit higher than the y-intercept, which makes sense, right? It does look a little bit taller than your y-intercept. So that answer does make sense. Now, if you were asked to find this equation, but you were told to find it in standard form, all you would do is expand this, right? Multiply it out, you would FOIL these brackets and then distribute in this A value, and you would get it in standard form. If you were told to put it into vertex form, then you would simply, after putting it into standard form, complete the square, and then it would be in vertex form. We have full videos covering how you can change the forms of functions, so definitely review those if you need to do that. Let's look at another example. Let's say that we're told the vertex of a function is -2, 4, and we also have a point, and the point is 3, -1. So with this information, how could we possibly come up with the equation of the function? Well, we can start by sketching what we have, right? That's always a good place to start. So you have your x, y axes here. So we're told the vertex is at -2, 4. So somewhere here, like that. And we have the point 3, -1. So 3, negative 1. So if this is the vertex and you have a point down here, it should be obvious that it's opening down like this. That's the only way it can touch this point down here, right? So we already know the direction of opening. Okay, now what else can we do? Well, because we're given the vertex, it'll be easiest to find the equation in vertex form, right? Because vertex form says you have y is equal to a times x plus the x value of your vertex squared plus the y value of your vertex, right? Well, the x value is negative 2, so you would put plus 2, and the y value is 4, so you put plus 4. Okay. The only thing that's left to find is your a value, and to find that, all you have to do is plug in this point for x and y. So you plug that in. Negative 1 equals a, 3 plus 2 squared plus 4. 3 plus 2 is 5, 5 squared is 25, so you get 25a plus 4 is equal to negative 1. Bring the 4 to the other side, you'll get negative 5. Divide both sides by 25, you get negative a fifth is equal to a. Therefore, your answer is y equals negative a fifth x plus 2 squared plus 4. This is the equation of this function, and you can see that it makes sense because the vertex, right, negative 2, 4, 2, 4, and the a value is negative, it opens down, so it does look like our final answer here makes sense.